Hello, I would like to demonstrate programming this part in Cimatron E version 10. Let's begin by exporting this file to an NC document. And next I'm going to switch to the CAD environment and we're going to set up some sets or levels. The first level is called rough, and we're going to select all the surfaces and next we're going to create a set called 3D, and we're going to select just the surfaces that would require a ball tool to run over them to put these ones on. Okay, and last we're going to create a set called check, and these will be all the check bases that we'll discuss later. Okay, now we're switching back to the CAM environment and we're going to create a new toolpath folder. This sets up the clearance height, and typically we would have one toolpath folder per setup, whether it be the top or bottom or whatever. Next we're going to define the target part. We could also use this to define fixtures such as angle plates or clamps. Next we're going to define the stock. We have a lot of different options for defining stock. In this case it'll just be a bounding box with an offset of 50 thousandths. Next we're going to create a procedure. And the procedure is using the part surfaces that are on the set or level that we called rough. No need to reselect anything. And everything we have here is going to be formula driven, so we're not going to make any changes. In the comment you can see that I'm leaving 10 thousandths on the walls and 5 thousandths on the floor, and I've copied and pasted that procedure down, and I'm going to add a different tool. Now we're going to use a 1/4 inch tool with the same settings for the amount of offset that we're leaving, but I would like to intentionally make this tool a bit too short so that there are some areas that get left unmachined. Okay, now we can see that the tool is indeed too short, and we're going to go ahead and process it with that tool at the appropriate length for the job so we can keep the RPM and feed rate high in order to machine it efficiently. Here's the result with the 3/8 tool. Okay, and here's the result with the 1/4 inch tool at the same offset as the 3/8 tool. You can see that the only motions we have are where the 3/8 tool couldn't get and the 1/4 inch tool is trying to get to. And that's a nice result, but it's not really what I wanted. What I really want is I want that tool to remachine everything a little bit closer. So we're going to change the offset amount to be 8 thousandths on the walls and 3 thousandths on the floors. And then we're going to re-execute and see the difference. Okay, and while that's executing, we're going to copy and paste, and we're going to grab the longer tool and we're going to calculate with the longer version of the 1/4 inch tool. And then we're going to take those two procedures, copy and paste, and change the offsets again. And this time we're going to still be 8 thousandths away from the walls, but we're going to take the floors to 0. And this will basically be a floor milling procedure where we can finish all the floors to 0, but we're still leaving a little bit of stock on the walls. Then we copy and paste again, and this will be bringing the walls in to 0 as well. Okay, so that one's just floors. This one is also just floors. Look at those ones executing, and then we'll edit the last two. And these ones are still just floors, but we're taking the walls to 0. And this is really what's neat about this, is that the result of this one is going to be just like we spent a lot of time doing a lot of chaining to do 2D machining, only we're not spending a lot of time doing chaining, and we're not giving a lot of care to having all the Z levels be right. We're going to let the software take care of all of that for us. And even if you had multiple offsets, like I know that with this type of machining, a lot of times what you'll do is you'll machine it to 15 thousandths away, and then 8 thousandths away, and then 3 thousandths away, and maybe then go to 0. Well, we can set all of this up in the toolpath folder and then copy the whole toolpath folder down and have the different offsets. So you would have the different toolpath folders having the proper amounts. Okay, here we can see the short version and long version separately. The red obviously is a longer tool, and the blue is the shorter tool. Okay, and then here we have the floor milling that's 8 thousandths away on the walls with the short tool. And then again the longer tool just doing the floor milling where it needed to go. Alright, and then finally let's look at the finishing of the walls. And again, we got the long tool and the short tool. And now we're going to do the outside perimeter. Now as I chain this, you'll see that I'm picking different Z levels, but it's all being projected down to the level of my very first pick. And it's even doing trimming and extending as well. So it projects down and then it trims or extends in order to keep a nice closed contour that's very forgiving based on the different geometry along the top. Okay, now that we have the outer contour, we can use that to create a procedure or we can also use it as a boundary. Currently I'm recalculating it in order to have a boundary here that will keep my tool inside that containment boundary. And again, while that's calculating, we can be setting up our next procedure, and this time we'll use the contour to actually do the 2D machining around the outside. And we'll pick a start point. And we can pick anywhere on the model to get a Z value, and we can do math inside of the field as well. We're going to apply cutter compensation, set the RPM and feed rate, and then calculate. Okay, so let's again review a couple of the results here. We've got the short tool, the long tool, and the outside perimeter all being shown. Okay, next we're going to work on the areas that we called 3D in our levels. And for the check surfaces, we're going to select what we called check earlier. Here we need a ball cutter. I currently don't have one, so we'll create one real fast. and we'll choose a spiral collapse working from the outside in. And we'll give it a step over of 5 thousandths. Set the RPM and feed rate. And calculate. Okay, now this result is a little bit more machining than I was hoping for. So we're going to go back and change the surface offset for the check surfaces to be a positive value instead of a negative value, so that we can contain the toolpath a bit more. And we'll re-execute that and see what kind of result we get. Okay, here's a better result where the tool is more contained, but I can see I have the high-speed motions turned on right now where all the corners are being rounded off, and while that's good in many cases, it's not the result that I'm looking for right now. So we're going to go in and turn that off. And then we'll save and calculate. Okay, here we go, that looks better. Okay, I like that. Now we'll do another procedure, and we're going to do drilling, automated drilling. And when we go into the auto drill environment, it shows us in light blue all of the holes that could be done. I can pick one and say select similar. It'll go out and find other holes that are like it and put those in a group. I can pick another hole and say select similar, or I could just box pick all of the holes and it would put them all in groups on the right hand side. The reason I'm only picking a couple of these right now is because I want to do these ones from the top side and I want to get the other holes from the bottom side, so that's why I was being selective in what I picked. And now what I'm doing is I'm going into a library of templates that says auto fit, and what that does is it looks to see if I've programmed any holes like this in the past, and based on a geometric range it will apply a template to this geometry. And by a range, what I mean is that, like for a diameter of 1/2 inch 13 tap, you might have anywhere from 421 to 422, and we set that as a range. So this one found one sequence and applied it. Looks like it did the little 1/4 inch reamed holes there on the pads. But we need to do one manually. So we're going to take this one and we're going to apply a template to it for a 1/4 inch flathead cap screw. And in comes information about doing those before. And I'm just going to check all the depths and see if they're okay. And it's actually good. So even though it didn't automatically get programmed, there was almost no work to be done to make it happen manually. Okay, so now we'll execute that and play it. Here it does the center drill on the pads. Oh, and the other ones too. So it's making an intelligent decision about, hey, I've got the center drill and the tool holder. Let's get all the center drilling done that has to be done. And whatever process you assign to this is the appropriate process. So like with that reamed hole, I believe I sent an end mill in there to straighten the holes out prior to bringing the end mill in. So however you program something is the appropriate way. Okay, so now we want to work on the other side. So we're going to create a new coordinate system facing the other direction. And we're going to apply another toolpath folder. Set the clearance plane from side 2. And I'm going to take one of these procedures from the first side and copy and paste it down below. And we're going to set the appropriate coordinate system. And I'm just going to go in here, verify it's what I want, and then hit save and calculate. And I can copy and paste again and keep right on going. This time we don't have any need for short and long tooling. We have some shallow work here to be done. So again, I'm just doing copy and paste. We're going to change a couple of the offset amounts. We're going to leave 8 thousandths on the wall, 0 on the floors. Floors only. Save and calculate. Copy and paste. This time we're going to go right to 0. This will bring the walls into 0 after the floors have been done. Okay, now we're going to finish the drilling from the opposite side. This time it knows what holes were done, and everything that's left needs to be done from the side, so I box pick all of it. It creates groups on the right hand side. I hit auto fit for previous sequences. It checks the library. It looks to see if it's done any holes like this before. Again, it's based on a range. You get to set up the range and say from this diameter to this diameter this happens, and you can set the depth. You can set everything that is relevant to that hole can be part of the criteria. So it's a very flexible way that we've written the automated drilling to work. And actually, I want to point out too that while that's calculating, I'm calculating the auto drill, and I'm also calculating all of the procedures. So a lot of background calculation going on, and we don't have to slow down for any of it. Okay, so here's the result. We got the 3/8 cutter coming from the back side. It knows what stock was cut away. Here's the 1/4 inch cutter just going into the corners. Again, chasing the stock. Here's the 1/4 inch tool doing the floor milling, leaving 8 thousandths on the walls. And then last, here's the 1/4 inch tool taking the final cut off the walls, just like a 2D procedure that you would sit down and write. And last is the automated drilling. We can play through this. Again, it's going to center drill all the holes, not wear out your tool changer. And that's pretty much it. This is what I think is a very efficient way to program a part like this in 3D on surfaces rather than using 2D and having to chain a lot of things.